Hello everybody, this is Wafula Alan Samuel, a math physics teacher. Today I will be taking you in mathematics, and basically we shall look at circles today. When we talk about circles, this defines an equation of x squared plus y squared plus 2gx plus 2f of y plus c equaling to a 0. So when we look at this, I can take an example, like we talk about a goat tied to eat the grass in a fixed point. So the rope shall take it to be our radius. So if a goat keeps on eating the grass with a fixed thread, we are going to describe a circle. So we have been dealing with most circles, but sometimes we don't know. For example, if I rotate from this point to other point, I move in a curve form, but keeping the distance from the center to be fixed. When I get another curve, I'll get a circle. So tonight we are going to discuss about circles. And now in this case, we are going to come up with two circles, and then these two circles are superimposed and they will form a right-angled triangle. So we are going to be looking at orthogonal. When two circles are orthogonal, what does it mean? So when we talk about orthogonality of a circle, the orthogonality so here we are going to look at two triangles. So we take this to be the center, then also this one has a center. Then the distance from here, we can also be able to get it. Then we want to see to show that this circle and this circle, they are meeting at 90 degrees, or they are orthogonal. So for us to come up with such a case, given that we have the equation of this circle, let's say to have x1 and this also to be x2, so if we have these two defined formulae for two circles, and then they tell us to show that these two circles are orthogonal, what do we need for this case, for orthogonality? We just need to prove to it that if these are the two centers of the two circles, and we believe that each circle has got its radius. So if we call the radius of this circle 1 as the radius for radius 1, then for this one to be radius 2, then we shall say that this square will give us r1 square plus r2 square. So if this condition is achieved, so it clearly shows us that the two circles are orthogonal, or they are meeting at 90 degrees. So we are going to take an example. When they say prove that the circles x squared plus y squared minus 6x minus 12y plus 40 equal to 0, and x squared plus y squared minus 4x minus 4y, equal to 16 are orthogonal. So for us to show that these two circles are orthogonal, what we are going to deal with, since we saw in the previous lesson how to get the radius and the center of these two circles, so we are going to consider this to be circle 1, which is this one. Then we consider this to be circle 2, which is in this case. So therefore, I'm going to only look for R1 for this circle, R2 for this circle, then their common distance in between them. That means that I will also need to get their centers. So this is how I will start. So when we have this, we are going to just do it by completing squares for this case, by saying if I have x squared plus y squared minus 6x minus 12y plus 40 equal to 0. So here we shall start by saying it is going to be x minus 3 when it is a square, then plus y minus 6 square equaling this one would have gone the other side, which is a minus 40, then plus, we add what we have already have here, that is negative 3 square, then plus negative 6 square. So we shall end up having x minus 3 square, then plus y minus 6, everything square, which is equal to negative 40 plus 9 plus 36. So when we add a negative 40 plus 9, we are going to get a negative 31. So negative 31 plus 36, then this gives us, so negative 40 plus 9 plus 36 will give us a positive 5. So this gives us x minus 3 square plus y minus 6 square equal to positive 5. And this is already in form of x minus a square plus y minus b square equals to r square, implying that our center becomes AB and our radius r square is equal to our radius square. So therefore we shall compare this to this, and we shall say that for this circle, its center is therefore going to be 3, then 6. And then its radius becomes root of what? Root of 5. But then we add on some word called units. So this becomes the center for the first circle. Then we also come to the second circle, which we have seen that is x square plus y square minus 4y, and this gives you 16. So when we also complete squares, this gives us x minus 0 square, then plus y minus 2 square. This gives us 16 plus 4 plus 0. And this gives us x minus 0 square plus y minus 2 square equaling to 20. Therefore, the center, I can call it center 2. This is center 1. So the center 2 becomes 0 and 2. And then its radius 2 becomes root of 20. So this was called radius 1. So we remember we had said we want to show that these two circles are orthogonal. So thereafter, after we have got the radius, 2 radii, we are going to therefore go and substitute in this formula to show that if this square is equals r square plus r2 square. So therefore we shall get d. And you know that our d is going to be the distance between 2 points, between 2 centers, since we saw that this is center 1, this is center 2. So this d is the distance between these 2 centers. So thereafter, we are going to say a 3 minus 0 square plus a 6 minus a 2, but square. So this means that our d is a square root of 3 minus 0 is a 3. When you square it, you get 9. Then plus 6 minus 2 is a 4. When you square it, you get 16. So this gives us a root of 25. And this gives us 5 what? 5 units. So this gives us 5 units as our d. So we therefore go and put it in the formula that this square must be equals r1 square plus r2 square. And our d, we have just seen that is 5. So we shall put here, which gives us 25, equals r1. And our r1, we had also got it as root of 5. So we are going to say it is root of 5 square plus our r2, we had got it as root of 20. But also we remember it is square. So this gives us 25 equals 5 plus 20. Therefore, it is 25, which is equals 25. So once the two right sides hold, thereafter it shows that these two circles are orthogonal. So thereafter, we conclude and say circle 1 and circle 2 are orthogonal. So in most cases, before a student shows the orthogonality of circles, must put it in mind that we have to look for each circle's radius and also for the other radius. Then we also have to look for the centers, because if we don't have the two centers, then it will be very hard for us to get the distance between the two centers, as you have been seeing how we got our d. So you have to always put it in mind that before you get anything, you have to get the centers of the two circles. Then also you get the distance between the two centers. Once you have got that, when you substitute in, it will clearly show you. So how about if it had not been orthogonal? If it was not orthogonal, then I would show that this side is not equal to the other side. Hence, the two circles are not at 90 degrees, or they are not perpendicular, or their orthogonality is null and void. Thank you so much.